Welcome to the Explainer. Today, we're going to do something that feels a little bit like magic. We're going to take a bunch of cold, hard numbers and we're going to turn them into actual stories.
So, picture this. You're a teaching assistant and someone just hands you this wall of numbers. It's a list of 40 exam scores. And at first glance, it's just chaos, right? It's a total mess. And that's the big question, isn't it? How did the class actually do? Were these good scores, bad scores, just kind of meh? Right now, it's impossible to know. There's a story hidden in here, but we got to figure out how to make the data talk. To do that, we need a game plan. Think of us as data detectives. Our mission has 4 simple steps. First, we're going to organize everything. Then, we'll find the center of the story. After that, we'll see how spread out everything is. And finally, we'll put it all in context to get the full picture. All right, let's dive in with step 1. Before we can do any fancy analysis, we just have to bring some order to this mess. It's time to turn that jumble of numbers into something we can actually see. So the very first thing we do is make what's called a frequency distribution table. It sounds complicated, but it's not. We just group the scores into logical buckets. Scores in the 30s, the 40s, the 50s, and so on. Then we just count them up. And already you can see a pattern starting to take shape. But you know what they say, a picture is worth 1,000 numbers. By turning that table into a histogram, we get an instant visual. You can see it right away. The bulk of the students scored in the 70s and 80s, with just a few on the high and low ends. See? The story is already starting to come into focus. Okay, so our data is organized, but now we need to find its heart. We need to answer the question, what was the typical score? This is called finding the measure of central tendency, and it gives us a single anchor point for our whole story. For this job, we have 3 main tools. First, you've got the mean. That's just your classic average. Then there's the median, which is the number that's literally in the middle if you line up all the scores from lowest to highest. And finally, the mode, which is just the number that shows up the most. The key thing here is choosing the right tool. The mean is great, unless you have a few really extreme scores, what we call outliers. In that case, the median often tells a more honest story. Now, finding the center is a huge step, but it's only half the story. To really get what's going on, we also need to know how spread out the scores were. I mean, was everybody clumped together around the average? Or were there scores all over the map? I mean, just look at this. We've got 3 different classes, and believe it or not, they all have the exact same average score of 75. But look at how different their stories are. Class 1 is totally spread out. Class 3 is packed really tightly together, and Class 2 is mostly tight but with a couple of outliers. This shows you exactly why the average alone is never enough. So to measure this spread outness, we need a special tool, the standard deviation. Basically, it's one number that tells you how far, on average, each score is from the center. A small number means the scores are really consistent and clumped together. A big number means they're all over the place. It adds this crucial layer of depth to our story. Okay, so we've got a really good handle on the group now, but what if we need to compare 2 specific people, especially if they're not even in the same group? Well, our last tool is all about adding that crucial context. All right, meet Eleanor and Gerald. Eleanor got a 680 on the SAT. Gerald got a 27 on the ACT. Now, who did better? Their scores are on completely different scales. It's like comparing apples and oranges, right? You can't just look at the raw numbers. So that's the real question we have to answer. Who did better compared to everyone else who took the same test? We need a way to make a fair apples-to-apples comparison. How do we do that? This is where the Z-score comes in to save the day. The Z-score is our ultimate translator. It takes any score from any test and puts it on one universal scale. It simply tells you how many standard deviations away from the average that one score is. It's brilliant. So we do the quick calculation and we find out Eleanor's score is 1.8 standard deviations above the average for the SAT. Gerald's score is 1.5 standard deviations above the average for the ACT. Ah, now we're speaking the same language. And boom, there's our answer. Since Eleanor's Z-score of 1.8 is higher than Gerald's 1.5, we know for a fact that she had the stronger performance when compared to her peers. The Z-score gave us the context we needed to find the real winner. So, there you have it. We started with a completely meaningless jumble of numbers, and step by step, we've built a powerful data detective toolkit. We've got our histograms to visualize, our mean, median, and mode to find the center, standard deviation to measure the spread, and Z-scores to add context.
And these tools, they aren't just for test scores. You can use them for sports stats, for business, for science, for pretty much anything. Data is absolutely everywhere, just waiting for someone like you to come along and tell its story. So now that you have the toolkit, what stories are you going to uncover?